We're asked to find the Laplace transform, which is big F of s, of the function f of t equals sine 6t. So applying the definition of a Laplace transform below, we have the Laplace transform of sine 6t equals big F of s, which equals the integral from 0 to infinity of f of t, which is sine 6t, times e raised to the power of negative st dt. Notice how we have an improper integral here. So let's rewrite this using limit notation. We'll write this as the limit as b approaches infinity of the integral from 0 to b. So notice how we substituted b for infinity, and then we have the limit as b approaches infinity of the definite integral. And let's write the integrand function as e raised to the power of negative st times sine 6t dt. And now for our next step, we'll go ahead and find the antiderivative, or the indefinite integral, of e raised to the power of negative st sine 6t dt. Then we'll come back here, determine the definite integral, then determine the limit. So for our next step, we'll determine the indefinite integral of e raised to the power of negative st sine 6t with respect to t. This is going to require integration by parts, and I've included the formula for integration by parts here below. So we'll let u be equal to sine 6t, and we'll let differential v be equal to e raised to the power of negative st dt. So to find differential u, we differentiate. The derivative of sine 6t with respect to t would be cosine 6t times 6. So differential u is 6 cosine 6t dt. And to find v, we integrate, which means you need to integrate e raised to the power of negative st dt. This requires u substitution, where u equals negative st, differential u equals negative s dt, dividing both sides by negative s. Notice how negative 1 divided by s differential u equals dt. So we can write the integral as negative 1 divided by s times integral of e to the u du, which means with respect to t, v is equal to negative 1 divided by s e to the negative st. So now we apply the integration by parts formula. So let's write u times v as negative 1 divided by s e to the negative st sine 6t. Then we have minus the integral of v du. Notice v times du would be negative. This will become plus. Let's write this as 6 divided by s, then the integral of e to the negative st cosine 6t dt. Now this integral does not look any simpler than the original integral. Notice now we have cosine 6t instead of sine 6t. So for our next step, we'll apply integration by parts again. So we'll let u be equal to cosine 6t and differential v equal to e to the negative st dt, which means differential u is equal to negative sine 6t times 6 dt, or negative 6 sine 6t dt. And just as before, we integrate here to find v. V is equal to negative 1 divided by s e to the negative st dt. We need to be careful when applying integration by parts here, because it's going to be 6 divided by s times the quantity uv minus the integral of v du. So we have the original integral equals, first term stays the same, then we have plus 6 divided by s times u times v. Let's write u times v as negative 1 divided by s e to the negative st cosine 6t. And we have minus the integral of v times du. Notice that v times du is going to be positive, so this does stay as subtraction. And let's write v times du as 6 divided by s times the integral of e to the negative st sine 6t dt. Now for the next step, we'll distribute 6 divided by s here as well as here. So we'll have minus 6 divided by s squared e to the negative st cosine 6t. And then we'll have minus 36 divided by s squared times the integral of e to the negative st sine 6t. So at this point, it looks like we're going in circles. However, notice how if we compare the integrand function to the original integral and the integrand function to this integral, notice how they're the same. So these are actually like integrals. So we'll go ahead and add 36 divided by s squared times this integral to both sides of the equation, which would give us the integral of e to the negative st sine 6t dt. Then we'd have plus 36 divided by s squared times the integral of e to the negative st sine 6t dt equals, we still have these two terms on the right side, negative 1 divided by s e to the negative st sine 6t minus 6 divided by s squared e to the negative st cosine 6t. And now we're going to factor the left side. Notice how the integral is a common factor. So we factor out the integral. We'd be left with a 1 from the first integral, and we'd be left with plus 36 divided by s squared from the second integral. So this product is equal to the right side. Now for the next step, let's add 1 and 36 divided by s squared. Well, we know 1 is equal to s squared divided by s squared. So s squared divided by s squared plus 36 divided by s squared is equal to s squared plus 36 all over s squared. So let's go ahead and replace this sum with this fraction. And now for our last step, we want to solve for this integral here. We'll do this by multiplying both sides of the equation by the reciprocal of this fraction here. If we do that, we'd get the integral of e to the negative st sine 6t dt equals, well, the reciprocal of this fraction would be s squared divided by the quantity s squared plus 36, and then times the difference of these two terms. And now for our last step to find the in-depth integral, let's simplify this product. So we have the integral of e to the negative st sine 6t dt equals, notice how for this first product, one factor of s will simplify out. So let's write the first product as negative s e to the negative st sine 6t divided by the quantity s squared plus 36. And then for the second product, notice how both factors of s simplify out. So we're left with minus 6 e to the negative st cosine 6t divided by s squared plus 36. Now this is an in-depth integral, so we would also have plus c, a constant of integration. Remember, our goal here is actually to find this depth integral, then determine this limit to find the Laplace transform of f of t equals sine 6t, which means now we can write the limit as b approaches infinity of the antiderivative of e to the negative st sine 6t is negative s e to the negative st sine 6t divided by the quantity s squared plus 36 minus 6 e to the negative st cosine 6t divided by the quantity s to the second plus 36. The limits of integration are from t equals 0 to t equals b. So now we'll find big F of b minus big F of a, and then we'll find this limit. Let's do this on the next slide. So for the next step, let's substitute b for t. And then we'll subtract the value when t equals 0. So now we'll substitute 0 for t. So here we'd have e to the 0. Here we'd have sine 0. Again, here we'd have e to the 0. Here we'd have cosine 0. And now let's determine our limit. We should recognize by now, as b approaches infinity, e raised to the power of negative sb would approach 0, and the sine and cosine functions fluctuate between the values of positive 1 and negative 1. So these terms approach 0 as b approaches infinity. And we know sine 0 is 0, so this term approaches 0. And then for this last term here, e to the 0 is 1, cosine 0 is 1. So this limit is equal to negative, and then in parentheses we have negative 6 divided by the quantity s squared plus 36. So simplifying, we get positive 6 divided by s squared plus 36, which is the Laplace transform of sine 6t. So now we know the Laplace transform of sine 6t equals big F of s, which equals 6 divided by the quantity s squared plus 36. So going back to our first slide, for entering a big F of s from the keyboard, it's important to enter 6 divided by, and then in parentheses, s squared plus 36. I think you'll agree in most cases, determining a Laplace transform using the definition takes quite a bit of work. Just like there are formulas to find derivatives, there are formulas to help find Laplace transforms. If you look at a table of Laplace transforms, you'll find a formula to find the Laplace transform of f of t equals sine at. Remember, in our case, we had sine 6t, which means a is equal to 6, which means big F of s, or the Laplace transform of f of t, is equal to a, which is 6, divided by the quantity s squared plus a squared, which in our case should be s squared plus 6 squared, or s squared plus 36. So after we get a feel for applying the definition of a Laplace transform, we'll just use the formulas from the Laplace transforms table. I hope you found this helpful.